Okay, so section 4 here is entitled Complex Numbers. So do you guys remember working with complex numbers? What about imaginary numbers? Okay, so all a complex number is a number that has a real part and an imaginary part. So they start with a review of what an imaginary number is and where it comes from. Imaginary numbers are legit numbers. They are used in engineering. They're used all the time in engineering. So they are poorly named to be named imaginary. People think imaginary means they don't exist. They do exist. They just are poorly named. So it says some quadratic equations have no real solution. For instance, the quadratic equation x squared plus 1 equals 0 has no real solution because there's no real number x that is squared to produce negative 1. So what they're saying is, here, if you take this equation, x squared plus 1 equals 0, and you solve it, so I subtract 1, and then we take a square root of both sides, then we get x equals plus or minus the square root of negative 1. Well, what times itself is negative 1? Nothing. Well, nothing, right? So what we do is we define I to be an imaginary unit, where I is equal to the square root of negative 1. So let's just do a quick review of all of our imaginary unit parts. So we have I is equal to the square root of negative 1. We created that to fix the problem of taking a square root of a negative. Now let's go through all of the possibilities. So what if I multiplied both sides by I? Okay, well, what is I times I? I squared. And then what is the square root of negative 1 times the square root of negative 1? All right, well, let's think. What was square root of 2 times square root of 2? Like, how does that work? The square root of 2 times the square root of 2 is the square root of 4. Well, what is the square root of 4?
All seniors will meet with the Balfour representative tomorrow, the 19th, Tuesday, at 1:15 in the high school library. An announcement will be made at that time. All seniors meet with the Balfour representative tomorrow. Thank you.
So what happened when we multiplied the square root of 2 times the square root of 2? Our answer is 2. If you multiply the square root of 3 times the square root of 3, the answer is 3. Essentially, your square roots cancel every time when you work those out. So think about what we did. If I multiplied both sides by I times I is I squared. Well, what would be the square root of negative 1 times the square root of negative 1? It's going to be negative 1. So when I multiply both sides by I, then I get I squared is equal to negative 1. Now what if I multiply both sides by I again? Well, I squared times I becomes I cubed. And then now I've got negative 1 times the square root of negative 1. So that's going to be negative square root of negative 1. See how I multiply both sides by I again to get there. And if I multiply both sides by I again, now I'm going to multiply this by the square root of negative 1. Well, square root of negative 1 times the square root of negative 1 is going to give negative 1. And negative 1 times negative out front is going to give positive 1. So you have I is the square root of negative 1. I squared is negative 1. I to the third is negative square root of negative 1. I to the fourth is positive 1. Now, what happens if I multiply by I on both sides again? That's going to give I to the fifth. And then on the other side, if I multiply by the square root of negative 1, well, 1 times the square root of negative 1 is square root of negative 1. So what's fixing to happen? You see the pattern? If I multiply by I to the, on both sides again, I'm going to get I to the 6th. And the square root of negative 1 times the square root of negative 1 is negative 1. Right? You got a pattern that's going to continue forever and ever and ever. So this is the way that we normally see it written, is we remember those 4 cases of I. Does that look familiar to you guys? And then also sometimes you'll see it written like this. I to the 0 is 1. I to the first is the square root of negative 1. I to the second is negative 1. And I to the third is negative square root of negative 1. They both are useful at different times. I probably normally write it this way, but it doesn't really matter. We'll talk more about it when we need it. Let's go back to looking here. So they talk about I squared is negative 1. So here's a quick review of imaginary numbers. By adding real numbers to real multiples of imaginary unit, you obtain the set of complex numbers. Each complex number can be written in standard form of a plus bi. So that's what a complex number is. It's in the form a plus bi. For instance, the standard form of the complex number negative or square root of negative 9 minus 5 is negative 5 plus 3i. So what they've done here, I know that it looks more confusing when you just have to look at it. If I had the square root of negative 9 minus 5, what we're going to do is, anytime we have a square root of a negative, we're going to rewrite it as negative 1 times whatever was underneath there. Because now we know if we take the square root of negative 1, we know that gives us I. And then I have the square root of 9, which is going to give me 3. So the square root of negative 1 is I. Square root of 9 is 3. So we've got 3i minus 5. And then to put it in the correct form, it's kind of like y equals mx plus b, where we put the x term in front of the constant term. Here you're going to put the constant term, the a term, in front. So this becomes negative 5 plus 3i. That's all that they did there. So again, there's may take a few different steps, but that's essentially what they have done to get there. Now, this whole thing is called a complex number. But the complex number has a real part and an imaginary part. The real part is negative 5. Because negative 5 is a real number. And you notice how it has no I with it, no imaginary part. So negative 5 is called the real part. Positive 3i is called the imaginary part. So let's see if I can. Put it here. This is the real part. This is the imaginary part. You guys remember any of that? Complex numbers, real and imaginary. So we're going to start here. We've got these 4 problems that it's wanting me to add and subtract these complex numbers. When we add or subtract the complex numbers, we're basically combining like terms. We're going to combine the real parts, and we're going to combine the imaginary parts. So the only thing you have to be careful about is when you have a negative. Because I'm subtracting all of this, that means I have to distribute that negative. But we'll get there when we get there. Okay, so if I'm looking here, because this is addition, I can essentially drop the parentheses. So if I combine the real parts, 3 and 2 is 5. If I combine the imaginary parts, negative I plus 3i is positive 2i. So when I add those, I get 5 plus 2i. Questions? B part, again, I have to distribute that negative because I'm subtracting the entire complex number. So once I do that, I'm going to have 1 plus 2i minus 4 minus 2i. Now when we group those, 1 minus 4 is negative 3. 2i minus 2i cancels. So that one, if you were asked to find the imaginary part would be 0. Because 2i minus 2i canceled. So that can happen. Now the next one, we have 3 numbers we're combining. We have a real number 3, then we're subtracting this complex number, and then we are adding this complex number. Okay, so first thing I'm going to look for is, if I'm subtracting, I need to distribute that. So that's going to become plus 2 minus 3i minus 5 plus I. And let's group them together. So the real parts, 3 plus 2 minus 5 is 0. So the real part of this complex number is 0. And then negative 3i plus I is negative 2i. The last one is 3 complex numbers. Okay. No, you're good. So now here, because I'm adding, I'm not really worried about these. I can drop the parentheses, but I'm subtracting this last one. So I have to make sure I distribute the negative. This becomes a negative 7 and a negative I. I'm going to bring everything else down. 3 plus 2i plus 4 minus I. So when I group them, group the real parts. 3 plus 4 is 7. Minus 7 cancels. That's 0. Now we combine the imaginary parts. I'll get 2i minus I minus I, which also cancels. So that time my real part is 0 and my imaginary part is 0. So my answer is just 0. I to the 0 is 1. I to the first is I. I to the second is negative 1. I to the third is negative I. That's the way we're going to use it here in complex numbers. Because when I did it before, if you'll remember, I left it as, like I to the third was negative square root of negative 1. Well, what is the square root of negative 1? That's just I. So that's negative I. Anywhere you had a square root of negative 1 before in our list, you're going to put an I there. Because I is the square root of negative 1. Anyways. So we'll have to go back and use that as necessary. If we don't have an I to the first, we need to do that. Right here, This works just like you think it would. You need to distribute because the 5 is out front being multiplied. So I distribute here. That gives me negative 10 and a positive 15i. Any questions on A part? Okay, let's look at B part. This time I'm going to have to distribute because I have a binomial times a binomial. 2 times 4 is 8. 2 times 3i is 6i. Negative I times 4 is negative 4i. Negative I times 3i is going to be negative 3i squared. So you'll see here, after I got done distributing, I have an I squared that I can't have in my final answer. So let's go ahead and fix that. What is I squared? It's negative 1. So instead of saying I squared, I'm now going to say times negative 1. I've substituted in negative 1 for I squared. Now we're just going to simplify this until we get a complex number. So 6i minus 4i is going to give me positive 2i. Negative 3 times negative 1 is positive 3. And then 3 and 8 is 11. So my final answer there is 11 plus 2i. That looks interesting. What makes this one interesting? It looks like it's factors as a difference of perfect squares. Well, what happens when we distribute a difference of perfect squares? No. If you multiplied this, x plus 2 times x minus 2. What cancels out? The negative 2x plus 2x goes to 0. So if I distribute those, I get x squared minus 4. If I distribute here, 3 times 3 is 9. This is going to be minus 6i plus 6i. Minus 4i squared. Now what is I squared? It's the same thing as negative 1. Negative 6i plus 6i cancels, is gone. So now I'm going to bring the 9 down. So that gives me 9 plus 4, which is 13. Okay, these two factors are special kinds of factors. I've used this word before. Does anybody remember what they are? What kind of factors would I say they are? Yeah, very good. Those are conjugates. If they look like they factor as a difference of perfect squares, then we call those two factors conjugates of each other. Well, what's so cool about when I multiplied conjugates? The imaginary part is gone. So when we have some problems we have to do later where I have to eliminate the imaginary part, That's a good tool to have in my toolbox. I can multiply by the conjugate. So just make a note of that. A couple of more here to work. So if I distribute here, 4i times negative 1, that's going to give me negative 4i. 4i times 5i gives me positive 20i squared. But I can't have an I squared in my final answer. So I know I squared is the same thing as negative 1. So this is going to give me negative 20 minus 4i.
But does it matter which one comes first?
Yes. A plus bi. Complex numbers are always in the form a plus bi. So we're going to put the real part first, the imaginary part second. Every time. Okay, E part. I'm squaring the entire complex number. What does it mean when I square something? I'm multiplying by itself. So 3 times 3 is 9. 3 times 2i is 6i. 2i and 3 is 6i. 2i and 2i is 4i squared. I squared is the same thing as negative 1. 6i and 6i is 12i. And so I have 9 minus 4, which is 5, plus 12i. So I've got two problems here, A and B. It tells me to multiply each number by its complex conjugate. So if I start here with 1 plus I, and I have to multiply this by its conjugate, what is the conjugate going to be? 1 minus I. We just change the sign between them. That's how we create the conjugate. So then we distribute, because it tells me to go ahead and multiply. 1 times 1 is 1. This is going to be minus I plus I, which cancels. And then I have minus I squared. But we said I squared is negative 1. So this is 1 plus 1, which is 2. Again, every time you multiply a number by its conjugate, the middle two terms, when I distribute, cancels. The outside and the inside. So I know you guys like FOIL. The outside and inside cancel out every time. You just have to multiply the first and the last. Any questions on A part? B part, I'm starting with 4 minus 3i. What is its conjugate? 4 plus 3i. Change the sign between them. And then we can multiply. That's going to be 16 minus 9i squared. I squared is -1. So it's going to be 16 plus 9, which is 25. And again, no imaginary parts left when I multiply by the conjugate. We finished with these? Everybody's good? Okay, now we're going to take a number written as a fraction and we have to rewrite it as a complex number. So what makes this so bad is the denominator is a complex number. I'm dividing a complex number by a complex number. Well, it would be really nice if I could somehow get rid of an imaginary number in the denominator. Do you guys know any way we could get rid of an imaginary number in the denominator? Multiply by what? So I heard it. Conjugate. If I multiply the denominator by 4 plus 2i, then those imaginaries are going to cancel. Okay, but here's the deal. If I multiply the denominator by 4 plus 2i, I have to multiply the numerator by 4 plus 2i. Because what that makes it look like is now I'm multiplying by 1. So when I multiply by 1, I'm not changing the number. I'm just changing the form. Okay, so we're going to do the multiplication. So let's multiply in the numerator first. 4 times 2 is 8. 2 and 2i is 4i. 3i and 4i is 12i. 3i and 2i is 6i squared. And now in the denominator, because I'm multiplying conjugates, I know the outside and the inside cancel. So I'm going to be 4 times 4 is 16 minus 4i squared. You want to simplify that up some? I've got 8. These combine to be 16i. This is going to give me a -6 here, right? Okay, and then in the denominator, I'm going to have 16 plus 4, which is 20. Is everybody with me? I know I'm kind of combining some steps. All right. Now, 8 minus 6 is 2. So I've got 2 plus 16i all over 20. Well, now if I have to write this as a complex number, then I've got 2 over 20 as the real part, 16 over 20i as the imaginary part. So now 2 over 20 is 1/10. 16 over 20 is 4/5. Homework. So I'm going to write the answer on the board here. And if I need to work it, I can. Right there's what you should have gotten. 3/5 plus 4/5 I. Okay, so if I'm working the problem out, I've got 2 plus I over 2 minus I. We have to write it in standard form. That means we cannot have any imaginary numbers in the denominator. So the way that we can cancel out the imaginary numbers is we can multiply by the conjugate. So the conjugate is just where we swap the sign that's between the terms. So because I wanted to cancel the denominator imaginary term, and it's 2 minus I, I'm going to multiply by 2 plus I on top and bottom. Now once I do that, that's going to give me 4, I'm in the numerator, plus 2I, plus 2I, plus I squared, over, and now when we multiply by conjugates, remember the outside and inside terms cancel. So that's going to give me 4, and this is going to give me minus I squared. Now I need to simplify this up. So first thing, I cannot have I squared. So everywhere I see an I squared, I'm plugging in -1. So it's 4 plus 2I plus 2I minus 1 over 4 minus, and then -1. Again, plugging in for I squareds. I'm putting -1s there. Now combine like terms. 4 minus 1 is 3. 2I plus 2I is 4I. And this is all over 4 plus 1, which is 5. And now to make it look like a complex number, we're going to write each term over 5. So I have 3 over 5 plus 4/5, and then put the I beside it instead of leaving it in the numerator. Okay, so the first thing we're going to do is we're going to practice by rewriting these radicals with negatives underneath them. So right now, when I have a negative underneath the radical, it will not work. I can't do anything with it because this is not a valid number. So the first thing I have to do always is I have to take care of the negative. I can't do anything until the negatives are gone. So the square root of -3 is the same thing as the square root of 3 times -1. And then same thing, the square root of -12 is the same thing as 12 times -1. Now because I have square roots of -1s, I can bring those out front as an I. So this is I radical 3, and then over here I have I radical 12. Everybody follow what I'm doing. Square roots of -1 is I. So whenever I have square root of -1 underneath, bring it out front. Now we just multiply. So I times I is I squared. And then I have radical 3 times 12. Well, 3 times 12 is 36. Radical 36 is 6. Then I still have I squared. But remember, we can never have I squared in our final answer. We can only have I to the first power. So I'm going to substitute in. I squared is the same thing as -1. And 6 times -1 is -6. I is what? I is the square root of -1. That's where I comes from. Anytime I take the square root of -1, I can just replace it with an I. That's where we began yesterday as our imaginary unit. So right here, when I had this broken down as the square root of -1 underneath there, the square root of -1 is I. So again, I've got these negatives underneath the square root. So you saw the process that I did. I'm going to write it times -1. Essentially what's happening is I'm pulling an I out. Right? So I have I radical 48 minus I radical 27. So now for you guys, you're going to put radical 48 in your calculator. I feel very confident that's what y'all would do. I know 48 is 16 times 3. So that comes out as 4I radical 3. Because back in my day, our calculators didn't break down radicals for us. I do it on my own. Back in my day. Okay, then over here on the other side, I've got radical 27. 27 is 9 times 3, so that's going to be 3I radical 3. So again, I think you guys are going to put this in your calculator. You're going to get 4 radical 3. Then you're going to put this in your calculator, and you're going to get 3 radical 3. Everybody with me? And the i's stay there. They're just like variables. Now, I can combine these. They are like terms. They both have an I radical 3 with them. So I have 4 of these I radical 3's, and then I'm subtracting 3 of these I radical 3's, which means I have 1 of these I radical 3's left. And then again, if we want to write it like in complex form, I should probably flip that around and have radical 3 times I. They're the same thing, right? It's just a notation type deal. The reason I didn't do this is because I got in the habit of not doing this because you have to make sure the I is not underneath the radical. Okay, now let's look at this one. Now I have -1 plus the square root of -3, and that's all squared. Okay, so before I worry about the square, I need to fix this negative underneath the radical, because that's not going to work. So this is the same thing as -1 plus I radical 3 squared. Right, pulling the negative out front, making it an I. Now when the entire parentheses is squared, that means I'm multiplying it by itself. So I have -1 plus I radical 3 times -1 plus I radical 3. That's what squaring means. And then we're going to distribute. -1 times -1 is 1. -1 times I radical 3 is -I radical 3. I radical 3 times -1 is -1 I radical 3. Okay, then right here's the tricky one. Right, so I've got I radical 3 times I radical 3. Well, I times I is I squared. Radical 3 times radical 3 is just 3. Those radicals cancel. All right, what do we do next? We have an I squared. Can't have an I squared, so I'm going to substitute in. That's going to be -1. Then I have like terms here. -I radical 3 minus I radical 3. That means I have -2 I radical 3's. And then bring down the 1 that was out front. Now then I have 1 minus 3. Right, if I multiply that out, that's a -3. So 1 minus 3 is -2. Then I have -2 radical 3 I. So again, I'm just rearranging it to make it look like a complex number where the I is at the end outside the radical. I've got negatives underneath radicals. I have to bring them out. So this is I radical 14, and this is I radical 2. Now we're going to multiply. I times I is I squared. 14 times 2 is 28. And now you guys in your calculator are going to put in radical 28. That's going to be 4 times 7. So that should be 2 radical 7 times I squared. Right, that's what radical 28 is 2 radical 7. And then I can't have an I squared, so I squared is negative 1. So that means I have negative 2 radical 7. So same thing, I got to get the negatives gone. So that's I radical 80 plus I radical 45. So I'm thinking of my perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81. All right, I've gone over them both. So let's just focus on 80 first. 64 times something is 80. No. 49 times something. No. 36 times something. That'd be 36 times 2 is 72. So no, that's not going to work. 25 times something is 80. 25, 50, 75, 100. No. 16 times something is 80. 16, 32, 48, 64, 80. So yes, that will work. You know how to do this if you can't? So just do 80 divided by 16, right? And see what works out. So 80 can be rewritten as 16 times 5. Now do the same thing for 45. So 45, let's see, 36 times something, no. 25 times something, no. 16, no. But it is 9 times 5 is 45. So I can rewrite that as 9 times 5. Now the square root of 16 is 4. The square root of 9 is 3. And now I have like terms. They both have a radical 5 and an I. So I can combine them. So I have 4 of those I radical 5s plus 3 of those I radical 5s, which gives me 7. And then I'm going to put the I at the end so it looks like a complex number in standard form. I got a negative underneath the radical. It has to come out front as an I. So I have 4 minus I radical 2. Squared means I'm going to multiply it by itself. Distribute 16 minus 4I radical 2 minus 4I radical 2 positive I squared times 2. Questions on that step? That's probably one of the trickier steps. Okay, now I squared is negative 1. So that's going to give me a negative 2 over here. So when I combine them, 16 minus 2 is 14. And now these are like terms, so combine them. I have negative 4, and I'm going to subtract 4 more. That's negative 8 radical 2 I. Back to what we were doing in our last few sections. We're asked to solve. So we're finding the solutions. That means we're finding the x-intercepts, finding the roots, all those words. Okay? Both of these are quadratics. They're x to the second. So because they're quadratics, that means I can use the quadratic formula. So on B part, I would definitely use the quadratic formula. But on A part, I wouldn't. You can use it on A, but I wouldn't. Because A is pretty easy to solve on its own. So if I have x squared plus 4 equals 0, if I just get x by itself, that means I'm going to subtract 4 from both sides. Then I'm going to take a square root. So the square root of x squared is x. Now whenever I choose to take a square root, I must account for the positive or negative possibility. And now what do I have? I have a negative 4 underneath the radical. So I can bring the negative out front as an I. and leave the radical 4 underneath there. And then what is the square root of 4? That is 2. So that is x equals plus or minus 2i. So those are my two roots. That still doesn't cross the x-axis, but it does have two roots. They are imaginary. Okay, then B part, you can't do that on B part because I have two x's. Right, so I can't just get x by itself. So the only things that I have to do, I could try to factor, which it won't factor, which means I have to use the quadratic formula. So when I'm plugging this in, this is my A term, this is my B term, and here is my C term. So I go x equals negative B plus or minus square root of B squared minus 4 times A times C all over 2 times A. Now we're going to simplify. So it's 2 plus or minus the square root of 4. That's 60 over 6. Somebody double check. 4 and 3 is 12. 12, I feel good about it. Okay, so that's going to be x equals 2 plus or minus the square root of negative 56 over 6. Now, negative 56, I'm going to bring out the negative as an I. So again, you can probably combine some of these steps if you want to. I'm just trying to make sure we understand everything that's going on. Now, 56, I have to break that down. So if you have a Casio, you can plug it in. If you don't, you have to do trial and error. So 4 and 19. 56 is 4 times 19. No, it's not. It's 4 times 14. Yeah. Yeah, that's better. Okay. Over 6. And then I can bring the 4 out. So the 4 coming out would be 2. And now everything out front here is even. So I need to divide them all by 2. So it's going to give me x equals 1 plus or minus 1 radical 14 I. And this is going to be all over 3. Which means I can write this as 1/3. Sorry. 1/3 plus or minus square root of 14 over 3 I. That way it looks like a complex number. So again, that's two complex numbers. Okay, the answer should have been negative 7/8 plus or minus radical 23, that's a 2, over 8I. Work it out. X equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So that's x equals negative 14 plus or minus the square root of 14 squared is 196. 9 and 8 is 72. 72 times 4 is 288. Is that right? Double check. Okay, over 16. And so it's going to give me x equals negative 14 plus or minus the square root of negative 96 over 16. It's not 96, that's wrong. Yeah. I will go for that. Okay, now I'm going to get rid of that negative underneath the radical, so that's negative 14 plus or minus I radical 92 over 16. If you got a Casio, you can put in 92. If you don't, trial and error. So I know it's going to be 23 times 4. So that's negative 14 plus or minus I 4 times 23 over 16. I'll bring the 4 out, it becomes a 2. Now everything is even, so I can divide them all by 2. So it's negative 7 over 8 plus or minus. The 2 goes away, so I've got radical 23 over 8. And then the I bring it to the back. Yeah.